Okay, AP Calculus AB, implicit differentiation and derivatives that are vertical lines. So let's find the coordinates of the 2 points on the equation x squared minus 2x plus 4y squared plus 16y plus 1 equals 0 on this closed curve where the line tangent to the curve is vertical. So the first thing I would do is this. I'll just share this with you guys so you could see it. This thing looks like this. And if you ever want me to teach you how, I'll show you how to put this into your TI Inspire or TIC Inspire CAS. But so here's our equation. And if you can see here that here we have this vertical tangent. We have a vertical tangent here and a vertical tangent here, and that's what we're looking for. So the first thing I'm going to do is go back to our work, and I'm going to start to take the derivative of this piece right here. So I'm going to take d dx of this whole mess here, and we know that the first derivative of x squared is just 2x, and the first derivative of negative 2x is just 2. And then here, this is where this gets a little interesting, because we have to use the power of the chain rule here. The first derivative of this is the derivative of the outside piece, right? So we're going to take the derivative of the outside. 2 times 4 is 8. Leave this junk inside. Decrement the exponent by 1. Now take the derivative of the inside. That's our g prime at x there. And the first derivative of y is dy dx. So we get dy dx there. So, and that was plus, so it's plus 8y dy dx, right? So we did that. Now I want to take the first derivative of the second piece, and some people it really bothers them because take 16y and you want the derivative of it. Remember, you have got to use the chain rule and act like this has an inside function. So take the derivative of the outside, which is 1 times 16, right? Decrement this, so the 1 minus 1 is to the 0, but so it's just the derivative of the outside is just 16, but we still have to take the derivative of this inside piece. And remember that the derivative of y is dy dx. And again, that was plus, so I'll leave it plus. So plus 16 dy dx. The first derivative of 1, of course, is 0. And the first derivative of 0 is also 0. So I took the derivative of everything. Right? So now we have to solve for dy dx. And when we solve for dy dx, and we move all this yellow crap to the right-hand side, so we'll get 8y dy dx plus 16 dy dx is equal to negative 2x plus 2. I'm going to go ahead and solve for dy dx, and we'll get dy dx. I'm going to divide everything by 8y plus 16. We get negative 2x plus 2 all over 8y plus 16. We want to know when this derivative, when we have a vertical tangent, means that the derivative is undefined. And we have to think about that. When the derivative is undefined, then the value of the denominator is equal to 0. So what we're going to do is pull this piece out of here and set it equal to 0. When we get 8y plus 16 is equal to 0, we solve, we get y is equal to negative 2, right? Just a little bit of algebra there. So that's a good start. That's a good start. So that tells us what the y value will be at these vertical tangents. So now we have to find the x value. So remember, we're looking for the values here. So we're going to go back through here, and we're going to substitute in the y value, which is negative 2. So we take our x squared minus 2x plus 4 times y, but y is negative 2, right? Squared plus 16y, which is again negative 2, plus 1 is equal to 0. This thing starts to clean up pretty good. Whoops, sorry. This thing starts to clean up pretty good now. And we get negative 2 squared is 4. 4 times 4 is 16. 16 times negative 2 is negative 32. Plus 1 is equal to 0. We're going to bring all this junk down and just keep simplifying. This is just algebra at this point, isn't it? And we're going to get x squared minus 2x minus 15 is equal to 0. See, this cleaned up really nice, didn't it? Now we're going to solve this quadratic, and we're going to get here that it's x minus and x plus, and it's x minus 5, isn't it? x plus 3 is equal to 0. So these are our factors. So when we solve, we get x is equal to 5 or x is equal to negative 3. And those are our two solutions. If you go back and take a look, we can see that. Let's take a quick look. And those points are right here, aren't they? The point is right there. So we get x is negative 3, y is 2. We have that vertical tangent right there, don't we? And the same thing, we get x is 1, 2, 3, 4, 5, negative 2. And again, we have our vertical tangents. Okay? So we have those 2 points that have vertical tangents on this equation. Remember, this equation is not a function. So, hope this was really helpful. If you haven't already subscribed, please subscribe. And your comments are always welcome. Thanks.